Welcome back to the channel, guys. So in last video I think we have discussed about many things. So it's been a long time since I've uploaded a video. I will try to be punctual from now on, guys. So in this video we'll be seeing about collection framework. So before going in dive with the collection framework, so let's understand basically theory behind the collection frameworks here. So the collection framework provides a set of classes and interfaces for representing and manipulating collection of objects. Okay, so what are these collections? So these collections are nothing but set of classes and interfaces. So what I mean by classes and interfaces are they are already pre-built classes and interfaces present for us to manipulate the objects. So we know the concept of objects, right? So objects are nothing but real world entity which we are representing in our program. So how to manipulate this using the pre-existing or pre-defined libraries present in the collection. So that's what basically the collection frameworks here mean. They are set of classes and interfaces are already present and implemented for us, so that we will be just learning how to use them so that we can manipulate our objects. As simple as that, guys. So it offers various data structures and algorithms to work with collections. Okay, what are these data structures and algorithms? Guys, these data structures are nothing but the data. So we know the primary task of these programs are to generate data, consume data, and manipulate data, right? So this data, how we will be organizing them so that they can be easily and effectively be used to our requirement is nothing but the data structure. How we organize them and use to use us, right? How we will be using them. That's the basic agenda behind this data structure. How we will be organizing them so that it can be easily and effectively utilized from time being. And what are these algorithms? So this algorithm basically fits into everything, guys. So this can be anything. This can be simple task of writing a program to compute the sum of two numbers, or this can be a complex program to compute the imaginary part of an mathematical operation. Can be anything. So this algorithm can be anything. So basically this algorithm are nothing but series of steps or the number of steps involved in doing a particular task. For example, let me say I want to do a particular task, and for that task there is a predefined set of operations needs to be done. For example, let's consider a simple task of making a coffee. In order to make a coffee, I need to take up the vessel, I need to add some water, I need to add some milk, I need to add some coffee powder, and finally need to boil it to make it a coffee, right? I'm bit yeah, I'm bad at making coffee, it's okay. Yeah, so basically like that. It's a series of steps of involved in performing particular task is known as an algorithm, guys. So we'll be seeing like they are predefined algorithms already present. For example, sorting a numbers, right? There are a different group of numbers present. They are unsorted. In order to sort them in increasing or decreasing order, we do need a certain set sorting algorithms. They are already predefined. They are already present and implemented for us to be used. So we'll be using those algorithms. Let's see the algorithms in coming videos. So basically these are the collections, guys. They are already predefined and implemented classes and interfaces for us to be present so that we can use to our requirement. As simple as that. So these are the interfaces, guys. So these are the interfaces present. So coming to the collection, the root interface of the collection hierarchy, it represents the group of objects, okay, known as elements. So these are elements here, which includes lists, sets, and queues, and even maps. So let me show that particular image. This image, guys. So an iterable is an interface. Under this there is a collection interface. Okay, under the collection interface there are set of interfaces already present. So the one which you guys are saving in blue are nothing but the interface, and the classes are represented in the green box. Okay, so list, queue, and set, as I mentioned, are some of the interfaces, and those interfaces have an implemented classes which are nothing but array list, linked list, vectors which comes under list, and finally array dq, which is a hierarchy of dq here, and priority queue comes under queue. Similarly, HashSet and linked asset comes under set, and there's an also sorted set interface. There's an implemented class known as TreeSet for that. I think in our course it's not mandatory, guys, like to learn all of these. Like most of the case we will be using ArrayList, and here, yeah, sets we will be using HashSet maybe sometimes. Let's consider on ArrayList and the other stuff like HashSet here. So let me go to the PPT. So here, if you see, the list represent an order collection of elements, a list of numbers, a list of names, a list of trees, like that, a list of tree names, anything like that, which allows duplicate elements and provide methods to access element by their index. So in list we can store duplicate elements, guys, so it's not an issue here. And also we can access the element in the list by using their indexes. So index start from 0, as you guys will be knowing that. And sets are represented of a collection of unique elements. So in set we don't like have the rights to store the duplicate elements. We can only store the unique elements and does not allow duplication of elements, as simple as that. So list and set will be using probably more in our full stack course. And coming to the queues represent a collection of designed for holding elements prior to process. So in queue there will be some priority being assigned to certain elements. So based on this priority we will be accessing the elements. So I think in our thing we don't have any queue implementation. But when it comes to queues, as I told, there will be priority being assigned to each and every element which you're storing in the queue. And typically this follows the first in first out order. So the first element to be inserted will be the first element to come out of the queue. That's the primary agenda behind here. And the map represents a collection of key value pairs. Each key is associated with exactly one value and keys are unique. So in map there will be for each element there should be a key and value. For example, key should be unique, right? So using the key only we will be accessing the value of the particular key, meaning that for an element, suppose say the 7 is the element which I need to store in the map, and that for 7 I need to store any particular key. So using that key like index, how we will access the list elements using the index, using the key we will be accessing the map elements. That's as simple as that. And if we go to the collection framework classes, as I told, like, there are many classes, so we will be concentrating on ArrayList here and HashMap in certain extent. Okay, implementing the list interface using dynamically resizable array. Okay, so this implements the list interface using a dynamically resizable array, means that so we will be dynamically allocating the memory for this array list. So we can dynamically allocate memory for this array list. That's what it offers, and offers fast element access but slower insertion and deletion compared to linked list. Okay, so this is related to some DSA part which we not require in our full stack, so we can forget this as of now. So you can keep in mind that they are dynamically resizable arrays. Okay, and linked list, so this implements the list interface using a doubly linked list and provide effective insertion and deletion operation but slower element access than array list. So if you need a faster insertion and deletion, you can go for linked list. And if you need a faster access, something like accessing an element's faster rate, like accessing 100 or 200 elements at a particular time, you could probably go to the array list, right? So that's the main difference between two of them. And HashList implements the set interface using an hash table and provides a constant time performance for basic operations. Okay, it performs a constant time, so it's basically faster than ArrayList and LinkedList in terms of adding, removing, and contains checking those operations. Okay, so these are particularly inbuilt methods which are predefined so that we can use them. Adding, insertion, deletion, I will show a simple part how it is done. Okay, and TreeSet is nothing but it's implemented using red black tree. So these are concept of DSA, guys. I think they're not quite like what to say, not quite important in our full stack aspect. So you can just go through this. So priority queues implements the queue interface using an priority heap. Okay, and HashMap implements the map interface using an hash table. As I told, HashMap this should be key value pair, right? So similarly a value will be associated with an hash value here. So particular, so for example, let's say 6 is the value which I need to show in the hash map, and this 6 will be having particular hash value. Using that hash value we can able to access this particular 6 element, right, like that. So basically it provides constant time performance for basic operations, put, get, and remove. Okay, assume the hash function displays elements properly. So in memory, when you like talk the concept of hash map, so it takes a less memory. For example, like for example, if you want 1000 elements, so it will be scaled down to their modulus value. Okay, so I think even that's not required in the full stack aspect. Just to keep in mind, so it uses some mathematical operation behind so that it can scale down the value of storing a larger amount of memory space. Okay, saving those spaces. Hash maps are being used, and tree maps are similar to hash map but in sorted map interface implementation, red black tree. Okay, and maintains key value pairs in sorted order. I think even this is not as required, guys. Concentrate on array list and a hash map onto some extent if needed. And coming to the framework operations, they are iterations. We can loop through all the collection interfaces and classes and get the values being stored inside them. Okay, and sorting, as I told, like we can sort the elements based on the already implemented classes present there. Okay, and also methods which we will be using shortly. And use for searching, we can also search for the elements present in the particular collections. Okay, and filtering and mapping, we can filter the data. For example, let's say around there are thousands records present and we need to filter out 10 records. Surely we can do that using collection framework. And mapping, so we can also map data here. So I will tell the mapping concept in detail in coming videos. Okay, and concurrency, as I told, like we can handle the concurrence axis here. They are pre-built concurrency mechanism which I will be explaining in the further videos. So let's get our hands dirty with the coding here. Okay. So basically, guys, this I will be teaching in my videos an array list, as I told, it's important, and hash set obviously will be the hash map to certain extent, not fully hash map. Okay, so for creating an collection here, we need to import the collection framework, guys. So this java.util.collection is the function. Like there are many functions have predefined methods present in this particular Java collection classes, guys. So this class object we need to interface here collections dot util collection so that we can use array list etc like here. Okay, so first we need to create an instance of array list, guys. So array list is also a particular class, as we know, as you have seen here, which comes under the list interface, right? This array list is a class which comes under the list interface, and this list interface comes under the collection interface, and this collection interface comes under the iterable interface. This diagram needs to be kept in mind. It has nothing to do with the coding, but this is a particular hierarchy which collections follow. Okay, so it's basically an object creation here, array list object creation, and we are storing that value in a list of string, right? In list of string, we are creating a list which contains the value strings in them, and we have given the name as string list of strings, the name of list here. So using this list variable, we're going to use a built-in method add to add an value which is an type of string here, because we have defined it as string here. If you define here as int, particularly we need to insert the integer value here. Okay, and similarly we are adding Python and C++ value to this particular list. Okay, which is of type of string. And now but to iterate here, we are using enhanced for loop here. Okay, for every string present in the list, we are taking a variable known as language and iterating it, and finally we are printing that, right? So these three values needs to be prompted in the console when we run this, right? Okay, and we are sorting this list. Okay, collections, we are calling the collections class, and inside that there is a particular method known as sort, and using the sort we are sorting the list here. I think it will be based on the ASCII values, I guess. So C++ will be first, like that. Okay, and we are printing the sorted list finally, and creating and adding an elements to the set here. So array list we have seen, and HashSet is also in class present. Where is HashSet? Yeah, HashSet comes under set, and as I told, in set doesn't allow the duplication, right? There should be no duplication. So let's try to see if we insert the duplicate element, it should not take, right? Let's see that while printing the sets here. Okay, and creating an adding key value pairs in the hash map. So hash map is also in class. Where is the hash map, guys? Yup. Okay, it comes under map. Okay, so basically this map, under that it comes in HashMap, right? Map is an interface, another HashMap is a class. So we're creating an instance of a class here, and we are storing string and integer, right? This is the key, this is the value, right? Key value. So string is the particular key of that particular value which we are storing here. So one which a value we are storing, and for that we are storing a key as one. So once we access using the key, we should need to retrieve their value, right? That's what been highlighted here. So iterating over maths for different function, guys. So normally we'll be like for the list and the set, we'll be just using as the normal array variables like that. For but there's a catch when it comes to hash map here, guys. So since there are key and value involved here, so iterating over map entries comes with different catch here. So let's see what's that. So for every map entry, you'll be using the map which we have created here. So this is a particular inbuilt class here. So for that every entry, string and value integer, okay, in this particular variable which we have created for entry set is the function which you need to use to get the access of each and every key value here. So entry dot get key, okay. So this variable will have the each value, each entry value here. Dot get key will give us the key. Dot get value give us the value of particular each and every entry present in that particular map variable, right? So if I run this, let's see. If I run this as I told, so here Java, Python and C++ obviously we should get, and once we sort it as I told, it will be sorted in the form of ASCII values. So C comes in the prior side, so C, Java and Python comes, and in the set as you told, the duplication is not allowed, so 20 is not been inserted in the set elements, okay. And coming to the maps, as I told, each and every element we are doing this, right? We are printing each and every entry here. So dot get will get the one value equal to our printing, and dot value will get us the value of the particular record in that particular map variable, right? I think that's all, guys. Just keep this diagram in the mind when it comes to the collections. So I will be coming up the file handling and few more concepts, and we'll wind up with this particular core Java session and directly jump to the Spring section, guys. So in Spring sessions, we will be seeing more about the backend, and I have decided to continue with the front end with the React particular framework. So we will be using React for our full stack here, guys. So stay connected, guys, and stay excited. So we'll be coming up with the Spring backend course in the Java. Okay, guys, see you. Bye bye.